Thank you everybody for coming. Welcome to Slashing Big Data Complexity, so how Comcast X1 powers analytics with Amazon Kinesis. My name is Liam Morrison, and I'm a solutions architect with AWS. And with me I have Charlie Hamill, who is a solutions architect with Comcast. So a little bit about what to expect in today's session. So first I'm going to go over what we have seen from our customers in their streaming data evolution. Then I'm going to cover the services that make up the Amazon Kinesis platform and how they all fit together. From there, I'm going to hand off to Charlie Hamill from Comcast, who will deep dive into the Comcast X1 platform and how Comcast is using it to build and share real-time analytics with their partners. Charlie's also going to cover some of the issues they faced along the way and some of the creative ways they're able to overcome those issues. All right, so let's get started. So what we have seen from our customers is that real-time processing applies to pretty much every scenario where data is being generated on a continual basis, in pretty much every market segment that we work with. So that includes ad tech, IoT, mobile devices, gaming, much more. So when our customers take on this streaming data journey, the first phase they tend to encounter is what we call the accelerated data ingest, transform, and load phase. So that's where you're taking real-time streaming data and pushing it into a data store or an analytical system for analysis soon after the fact. So it could be log data ingestion that you're pushing into a persistent store like S3. So very soon after that, they move on to what we call the continual metrics generation phase. So now that they've got this real-time data streaming into their systems, they're able to actually continually gain insights from that data stream. So finally, they move on to what we call the most sophisticated scenario, which is responsive data analysis. So that's when you're reacting to your data in real time, such as personalizing the user experience based on in-game decisions made in a mobile gaming scenario, or reacting automatically to mechanical issues in an IoT scenario. So the goal of the Kinesis platform is to provide scenarios and services that apply to each and every use case, and pretty much any use case our customers can think of. So currently, Kinesis as a platform is made up of 3 services. So back in 2013, we launched Kinesis Streams, which is a managed service for streaming data. So think of this as a foundational building block or primitive that enables developers to have complete control and flexibility to build their own stream processing applications using whatever tools they prefer. So last year at reInvent, we built on that and released Kinesis Firehose. So Kinesis takes what we learned from Kinesis Firehose takes what we learned from Kinesis Streams and makes the task of capture and delivery of streaming data extremely simple. So it provides several destinations that are persistent for that streaming data. So today, we launched Kinesis Analytics earlier in the day. So Kinesis Analytics is a stream processing counterpart to both Kinesis Streams and Firehose that enables you to express your stream processing applications in SQL without having to manage complex frameworks. So let's start with Kinesis. Let's start with Kinesis Streams. So Kinesis Streams, again, it's a managed service. So there are no clusters to manage, and it takes care of itself. You can do some simple work to scale it up and down. So on the left, you have what we'd call data producers. So data producers can be anything from EC2 instances, mobile applications, IoT devices, you name it. So you configure your data producers to push data into the Kinesis stream, and then on the other side, you put data into the Kinesis stream. So let's take, for example, Kinesis or Clickstream Analytics. So data from websites is sent into the Kinesis stream, which then processes that data. You can have full control over how the stream is organized, how you partition your data, how you scale your stream, how you read that data, and how you process that data. So a couple of the benefits of Kinesis Streams are easy administration. So it's very simple to create a stream and get started. So you simply create the stream, set your desired level of throughput, which is done by setting the number of shards in that stream. Then you can scale that stream to match the throughput needs that you have by simply adding and removing shards. The second is it allows you to build real-time applications. So it allows you to perform continual processing on your streaming data using things like the Kinesis client library, known as the KCL, Apache Spark, Storm, AWS Lambda, and more. And the third is it's extremely low cost. So using that sharding concept that I mentioned earlier, it allows you to scale your stream to handle workloads of any size. So you can get cost-efficient workloads at any scale. So a little bit about how to get data in and out of Kinesis. So the way Kinesis achieves that full flexibility is through the variety of options of both sending and reading data into the stream and from the stream. So sending data in the streams can be accomplished through a variety of different methodologies. That can be the SDKs, the Kinesis producer library, known as the KPL, or open source technologies like Log4j, Flume, or FluentD. So on the flip side, we also have a lot of different ways to actually read data from the stream. So at the very primitive level, we have the GET APIs, up to Amazon-provided methodologies such as the Kinesis Client Library, AWS Lambda, and starting today, Kinesis Analytics. Finally, we also have open source platforms such as Apache Spark and Storm. So this is not a complete list, but just some of the many options that are available to you with Kinesis Streams. So one great thing about the Kinesis Client Library and Kinesis Producer Library, KCL and KPL, is that these are open source libraries that we've built that are designed to make creating producers and consumers for Kinesis extremely simple. So this also handles a lot of the tougher parts and the throughput concerns, such as aggregating of records, reacting to shard changes, and much more. So in a little bit, Charlie's going to actually tell you about how they use the KCL and KPL to overcome some of the throughput concerns that Comcast saw. So moving on to Kinesis Firehose. So Kinesis Firehose, again, makes the process of loading streaming data into several common destinations extremely simple. So one of the interesting things we've learned from our work with Kinesis Streams is that one of the most common use cases that our customers saw was that they wanted to take streaming data and load it into a persistent store, which is kind of ironic, but that was one of the common use cases with Kinesis once they've got that streaming data. So on the left side, what you see is very similar to what you saw with Kinesis Streams, where you have producers like the Amazon SDK. However, once it goes into Kinesis Firehose, it is a fully managed service. So you don't have to deal with shards, you don't have to write consumers. It is just sending that data straight into the persistent store, which today can include S3, Redshift, and the Amazon Elasticsearch service. So thinking about it in the scenario of that first scenario we talked about, which is accelerated data ingest, transform, and load. So Kinesis Firehose is extremely good at that. So let's look at the sending and receiving with regards to Kinesis Firehose. So this is going to look very similar to what you saw with Kinesis Streams. However, on the left, you have data producers, which include the SDKs, mobile and standard Amazon SDKs, AWS IoT, and the Kinesis agent. So the Kinesis agent is a standalone application that monitors files and sends data records into your delivery stream without having to write a line of code. And it handles a lot of the standard issues you might have, such as file rotation, checkpointing, retry upon failure. The Kinesis agent also has some data pre-processing features. So it does things such as log parsing and format conversion. So one additional thing to note about the Kinesis agent is that it also works with Kinesis Streams. So it allows you to get data into Kinesis, both Firehose and Streams, without writing code. So the main difference here, now that it's in Firehose, is that Firehose, again, is fully managed service. So you didn't have to specify the throughput you needed. Kinesis Firehose just takes care of that. So you have your choice of destinations currently, which is S3, Redshift, and the Amazon Elasticsearch service. So if you're looking for more variety in ways to push data into Firehose or pull data from Firehose, or Kinesis in general, you're going to want to look at Kinesis Streams. So finally, we have Kinesis Analytics, which again, made generally available earlier today. So think of Kinesis Analytics as a managed Kinesis consumer, one that makes it easy to continuously query the real-time data using standard SQL queries. So it allows you to manage complex analytics without having to build a whole framework or manage a framework. So this allows you to iterate through many stream processing use cases very quickly. It will help you easily progress towards that goal of reactive data analysis. So a couple of the benefits of Kinesis Streams is that it allows you to take the SQL skills you have currently and manage them and apply them directly to a streaming data solution. Second is it also allows you to build real-time applications, but it allows you to do so without having to write a line of code or deal with things like Scala. And third is it scales elastically. So Kinesis Analytics is designed to scale with most workloads without having any operator intervention. So getting started with Kinesis Analytics is extremely simple. So it allows you to build an application with 3 simple steps. So the first step is you set where you want to get your data from. So you set your streaming source. And that can be Kinesis Streams or Kinesis Firehose. Second is you write SQL code to process that streaming data. So you can author applications with a single SQL statement, or you can build sophisticated applications with multi-step pipelines with advanced analytical functions. And the third is you set your output. So you set where you want those continuously delivered SQL results to go. So as of today, outputs can include Kinesis Streams, Firehose, S3, and Redshift. However, you can also use services like AWS Lambda and Firehose to configure custom destinations. So for more information about this, I definitely urge everyone to check out the session that starts in this room, actually right after this session. So there's a new launch session with Kinesis Analytics information. So now I'm going to hand it off to Charlie Hamill, who will go over the streaming data journey that Comcast took on and give you some of the insights that they found in their journey. There you go.
Thank you, Liam. How many of you here, just a quick poll, are Comcast subscribers? Great. The rest of you can leave. This is just about Comcast. No, I'm kidding, totally. Of you who are Comcast subscribers, how many of you have what you know to be X1? Great. For the rest of you, here's a short little video to give you just a tiny taste of what X1 is like.
This summer, the networks of NBC Universal are bringing you the most comprehensive Olympics coverage ever. And there's no better way to experience it all than with Xfinity X1. Find what you want to watch, when you want to watch it. By sport, by athlete, and by country. 11 networks, more than 6,000 hours. Every event streamed live on every device. Personalize your must-see moments.
And a 48-year-old record now belongs to Phelps. Number 19. No one has one more.
Enhance your viewing experience with the X1 Sports app. Dive deeper into the action with live information, athlete bios, highlights, and schedules. All available at your fingertips.
So that gives you a small taste of what X1 is like, at least some of it. You might have seen some very Olympics-specific menus and pages. You saw things about Rio in general. You saw sports events. You saw teams, countries, specific athletes. And it allows you to drill down into those things, and when you finally land on a page, take action, like watch an event that already happened on demand, or decide to record one that's going to happen in the future, or decide to even get a text message about when it's about to begin. All of that required really no code. It was all menu configuration and metadata for the graphics and things. And that's because, in general, it's a platform running in the cloud. Just to kind of repeat a point that Sri Kote made earlier today in the keynote, back in '96, NBC offered in Atlanta about 150, 200 hours of coverage. That was kind of manageable for most human beings. This time, it's about 6,800 hours of coverage they're offering. Not too manageable. So a system like X1 allows you to drill in on what you care about and decide how you're going to watch it. And that's another interesting feature. Putting everything in the cloud, you can watch it on all your screens. You can see things on your mobile devices, your PC, of course, your TV. Here's the challenge we took on when we decided to build the X1 platform. We decided from the start that it was going to be essentially an experience-only platform, and we were also going to make it a platform as a service that we would syndicate to other video companies. Certainly Comcast came first, but others have come along since then. That gave those of us in the data world a big challenge too, because we had to syndicate data along with all the other features to the partners who were going to be subscribers of the platform, or syndicators of the platform. In particular, they needed all kinds of data in order to operate the platform on behalf of their customers. Things like stream quality status, or VOD usage, or error rates, and things that customers were experiencing on their screens. So in order to do that, and not make it a best effort kind of practice, but now data is actually a feature of the platform, we had to latch on to the right design or an architectural pattern for getting that done. So we decided the answer was a data bus. Looking at the narrower context of this data bus environment, the big X1 platform has, on the one side, a lot of services that emit interesting and important telemetry data. Then in the middle, we have this area called Fairmount, which is the data bus I'll be talking about. And that does all the TLC kinds of things with data to make it useful for consumers. Things like receiving it and getting it where it needs to go, enriching it, making sure the quality is right. And then over on this side, we have all the consumers, which we call partners, or syndication partners, who need that data in order to run their businesses. So I'd like to talk specifically about the solution that we came to, the data bus. And I'd like to say three things about it. First, the data bus pattern and why that's an important idea. Next, the data bus foundation that we ended up with. And thirdly, the overall data bus ecosystem. So let's first talk about the data bus pattern. Just imagine you have, in a little environment, 6 participants who need to deal with data. A few producers, 3, and 3 consumers. If they were to directly connect with each other to get what they need, you'd end up with 18 connections maximum. And if we added just one more consumer to this mix, it explodes to 24 connections. That's exponential growth in complexity. It's a mess. It's hard to maintain, it's hard to fix when something breaks, and it's hard to extend. Now, if we take those same participants and put a bus in the middle, it's much simpler. With the case of just the 6 participants, it's only 12 connections, because each participant only needs 2 connections to the bus. They don't even know about each other. And if we want to extend it to a 4th consumer, it's just 2 more connections. That's linear growth in complexity. It's a lot easier to manage. Some other characteristics of a data bus that are important to us. First, it decouples senders and receivers. That's kind of like what I was just showing you. Secondly, it has extensible features for enriching, filtering, forking, duplicating, and storing data. And thirdly, it has topics, which are unique channels for specific data publications. And lastly, it's reusable. Any number of topics, producers, and subscribers can participate in this bus. And these qualities are difficult, if not impossible, when senders and receivers are directly connecting with each other. So next, let's move on to the second point I wanted to make, and that's the bus foundation. Here's where we were back in 2014 when we decided to build our own bus. It's probably a pretty familiar stack if you're into the big data world. We had things like Flume, Hadoop, Storm, Kafka, MemSQL. You might also recognize this as something some people call the Lambda pattern, not to be confused with Amazon Lambda. Across the top is the more batch-oriented analytics path, where you can do rich historical analytics and have a reporting front end like Tableau to represent it. And the bottom path is the more real-time streaming path for real-time urgency data. We went along with this for a while, but after a year, we were continuing to have challenges. Namely, with the Kafka bus, at this point, our mean time between failure was 2 weeks. Our mean time to recovery was 4 hours. The impact, well, it affected syndication subscribers, and it required extensive overtime for the staff. And the root causes of these problems ranged from data rebalancing on the Kafka cluster, infrastructure issues, zookeeper problems, and overloading by others, noisy neighbors. In addition to that, we had weak or missing features in this environment, namely multi-tenant guardrails to protect us from noisy neighbors. Elastic scale is very difficult to achieve with Kafka. Security was non-existent in 2014. It's there now, but it's pretty primitive. And lastly, geo-distributed high availability is very difficult to do. And we were at the point where we had to think about something different. Our second partner was just about to get started. Our first partner was already getting its streams directly from Kafka, and we really didn't like that arrangement. It presented an unpredictable load pattern inside of our data centers. It created a little bit of a security challenge, so we wanted to move away from that. And time and patience were frankly running out for this situation. So what we did is first thought, let's deliver these streams from Kafka out to a reliable and in sort of a DMZ-like environment for our partners. Let's ask them to establish Amazon accounts and give us Kinesis streams to forward their data to. That would solve security, high availability, and scale for us. So we did that. We worked with our partners, coached them on and pitched to them the benefits of doing things this way. We got their local Amazon teams on board and held their hands and got them going. And as it was moving along, the elephant in the room for us became, why are we still struggling with Kafka? So we pivoted and went with Kinesis as well. So as of about December, January of this year, this is what things looked like for us. We began building topics on Kinesis. We went through the learning curve. Our developers really started getting on board. But I have to say to you that our developers were initially kind of resistant. Now, in the X1 organization overall, we're a very invented here kind of mindset. We love open source. We love building everything ourselves. So getting a group of heady engineers to let go of some of that and move over to a managed service was a little bit of a persuasion effort on some of our parts. But they got on board. And as the more they got on board, they began to experience what we now call serverless computing, a little bit of it. And the relief of doing that became pretty palpable. They were liking it. And additionally, I could say that X1 overall, from the beginning, has embraced Amazon Web Services as infrastructure only. And this was one of the early steps into managed services for anyone in X1. So a lot of newness going on here and a little bit of culture shift. What happened then is some of us nudged the teams into more managed services to build out the capabilities of the Kinesis environment. And so we did. They already had committed to using Spark, they being the engineers. So why not do Spark on EMR, kind of a semi-managed environment, take away the server cluster management headaches? And think about Kinesis Analytics. We just got to know about that recently, and we're looking into it and starting to use it. What about Kinesis Firehose, a really easy way to archive Kinesis streams into S3? That was easy, and we did that early on. And what got really interesting is AWS Lambda as a computing platform. So Storm and Spark are great, but Lambda became pretty interesting as also a real-time processing environment, especially for producing and consuming streams into and out of Lambda, Kinesis. So there we were. So that's the data bus foundation. And I mentioned there were some qualities that were really important to us that were a little bit weak before. And these 4 qualities were multi-tenancy, elastic scale, security, and high availability. Let's talk about how Kinesis addresses those. First, with multi-tenancy. Now, by multi-tenancy, I mean something specific. On a data bus, I want to be sure that my capacity is mine and nobody can mess with it. And I'm pretty sure the other tenants feel the same way. Here's how Kinesis does that. The key here is something called the shard. And a shard has strict read and write limits on it. If you exceed the capacity, you will time out, either as a producer or a consumer. And that's what we want. If you need more capacity, you can ask for it. And closely related to that then is elastic scale. How do you scale with Kinesis? The idea is you ask for more shards. Let's say in this scenario, we're floating along happily with 2 shards. It's handling the load. But then somehow we detect hotness. And that means we're running out of capacity. Well, you can solve that very quickly by making an API call with a +1, meaning give me 1 more shard. In that case, the API will do a split. It'll take the data that's running in 2 shards and distribute it across 3. and let's say everything is happy at that point, and let's say actually things cool off, and you detect that it's too cool, you're probably wasting money, you've got too much capacity. You call the same API with a -1, and it'll take that one shard away and merge your data onto 2 shards now. So that's what we do. This is really easy, using the API externally to any of your consumers or producers, and have your consumers and producers just using the KPL and KCL, because they won't know about this adding and taking away of shards. I also want to tell you, just FYI, of something we got wrong, and maybe you'll learn from it. Someone on one of our teams tried to go it alone without the KPL and kind of misunderstood what a fundamental principle here is that Kinesis calls batching. And specifically, batching consists of 2 topics, one called collecting and the other called aggregating. So over on the left, imagine these are all your records that you're trying to jam into a Kinesis stream. You've got some sort of producing application looping along and throwing things into the API. Let's say it's the KPL you're using. So you're kind of blind to what's going on under the covers, but what the KPL is doing for you is something called aggregating. Aggregating tries to pack as much of your user records as possible into as few Kinesis records as possible to optimize how much you can get into the stream every second. In addition, there's something called collecting. When the algorithm in the KPL recognizes it's time to punt, it's time to get that payload out the door, every second, it will pass it on to an API called put records. Put records will optimize network bandwidth by putting all of those records that the KPL just produced into one call, minimizing network chatter. So aggregating maximizes your throughput per second, and collecting maximizes your network bandwidth. Where we got it wrong by not using the KPL is our producer was just looping through user records and doing put records calls, and our I/O through Kinesis fell through the floor. It was really bad. So next, thirdly, we talked about security as a feature we wanted. And Kinesis, being an Amazon service, has all of the familiar Amazon security features. So there's no question about that security is great. It's just a question of what options you want to take advantage of and how you want to use them. IAM credentials is one option, federation is an option, and cross-account trust is an option. And that's the one that worked best for us. So let me drill into it for just a second here. First, imagine that we have 2 accounts, which is what we have to deal with in our situation. We've got the partner who has to trust us to write to their Kinesis stream, as I mentioned, and we have us, the publisher, who needs to be trusted. How that works is first, the trusting account, the partner, needs to set up a couple of things, a couple of policies here. One, declaring a role and what that role can do. In this case, it's all about the limited rights that we want to have on Kinesis. Describe records, put records. And then they have to have another statement to describe what account can assume that role. That would be us in this case. Next, over on our side of things, we also have to declare what role we're going to let a specific participant assume in that other account. So here what we're saying is we're going to allow Lambda to assume that role in the other account. Now we can get into action here. The Lambda publisher can reach out to the other account and authenticate. Because of all the policy that the other side set up, they'll say yes, have at it, and return a temporary set of credentials that the publisher can use and go ahead and start writing to a Kinesis stream. And the nice thing about this is those credentials expire in an hour. They can expire sooner if someone wanted to manually take it away the privileges. So it's a very secure way of doing things. And it also doesn't proliferate IAM logins in all your accounts. That's a mess, doesn't scale very well. So that's great for us. The next quality I wanted to talk about, and it's the final one, is what I call opaque high availability. So high availability can mean a lot of things, but what I mean here is I want the service to be deployed across 3 data centers at least. Secondly, I want all 3 locations to be active. No active standby, no failover, failback. And thirdly, my applications shouldn't be aware of any of those data centers. Their point of contact should be a URL. And lastly, my applications won't know about a failure. If a failure happens in an entire data center, I want to just be redirected to one of the other two, and I don't want to know about it. So this is effectively what Kinesis does. Normally, the interaction is to a URL, and something is directing that URL to one of the Kinesis availability zones. I don't know, I don't care how that happens. And next, what would happen if an entire availability zone fails is that something in between would direct me somewhere else. Again, I don't know, I don't care. I'm happy. No failover, no failback, no replay or recovery, no message loss or duplication. Now, our third point of our solution I mentioned was called the data bus ecosystem. We've talked about the pattern and the foundation. Now the ecosystem. Why the ecosystem? Well, in spite of all the riches I've described so far with Amazon Managed Services around Kinesis, it still wasn't enough for our purposes. There are some additional things we had to build. We needed to build three things. We needed to build schema management. We needed to build self-service message routing, and we needed to define and establish security governance. So first, schema management. What is schema in this case? Well, schema is the thing that's going to describe what every single message looks like flowing through the bus for a particular topic. And it's a text template that defines the look of the message. It's JSON. Now, there's a lot of ways to do this. Google Protocol Buffers is one, Thrift is one, Avro is another. We chose Avro with a significant twist to it. So here's an Avro sample schema. It's just JSON, and it describes what an Avro message would look like for this particular schema ID. And what it would look like in the abstract is schema up top and a lot of data encoded as binary records below it. Avro has the concept of Avro containers. The idea is some process will declare the schema and serialize the schema and a bunch of records out to a container that ends up in a file. It's great for batch processing environments like MapReduce and Hadoop. But we wanted to hijack it and use it for streaming purposes, which it's not really designed for. Here's a particular Avro message. Actually, it's a container. The big blue part is the schema, a schema that defines 8 fields. And at the bottom there are 2 records, 8 bytes apiece. It happens to be a Twitter tweet. This wasn't going to work so well for us, because if we tried to stream anything like this, it would look something like this. Lots of schema and a little bit of binary data every second. So we had to figure out how we were going to do something different. What we did is this. We chucked the schema and instead created a custom header that's 8 bytes long, only 3 of which we're using right now. It declares the schema ID and the major and minor version of the schema. It's in clear text, and it's followed by the binary encoded single message. By doing this, we save about 60% of what we would have had if we used normal, straight out of the box Avro. And here's what it looks like over streaming. A little bit of header and a lot of binary data. Much better. But it begs the question, where is the schema now? What we created was a schema registry. And that's a lot like, if you're familiar with XML, like an XSD. An XML file can have a URL reference at the top that references the XSD that describes the UML message. It's a lot like that. There is an online schema registry that anyone who knows about it can refer to get the schema. And here's how it works. The producer of a message will create the schema and register it in the registry, then produce messages with that header on board that declares the schema reference. It flows through the workflow and the pipeline with a much lower payload. The consumer gets it, and the first time they will actually have to do a lookup into that URL that I mentioned and pull the schema down, cache it in memory, and keep it forever. Then, from there on out, as messages fly by, hundreds of thousands per second in our case, they are simply looking at that clear text header and very quickly making a decision whether they can accept the message or not. If it's a schema version that they've got, they're fine. They know how to interpret the message. And the second thing we had to build is something I call self-service message routing. It's kind of related to the schema problem. You might have heard in the keynote today when Sri Kote talked about how fast we deliver features. We do software releases in X1 at the rate of thousands per month. And that means lots of new data features. It might even mean existing data features have changed. And we have to be able to move at the speed of our production, at the speed of our innovation. And thus, we have to release new data features when we need to release them and can't be tightly bound to consumers' readiness to receive them. So it raises the question, how in the world can we move forward with new data changes, new schema changes, and not break the downstream consumers? Well, what we came up with was this. In the middle there, you'll see something called the publishing agent. And that's going to have on it, it's not quite done yet, another registry area. It'll be an extension of the schema registry that I already mentioned. And there we will publish schema versions, and consumers will be able to log on there visually and see what's going on. They'll get notifications automatically that new schema versions are ready, and they'll be able to make routing decisions about new versions of a schema when they come along. Let's walk through an actual scenario. Let's say right now, schema version 1.2 is the happy one. Everybody's got it, it's flowing through, it's going into the partner's production path. But let's say a new version comes along in our world. Let's say it's specifically a breaking version, I'll call it 2.0, meaning that an existing field that, say, was an integer is now an array of integers. That should break their consumer. They shouldn't know how to deal with an array. So we've got to release it. We've developed our code, our producer code around it. We need to push it into production fast and not be held back. So that's what we do. But because the router is not configured to do anything with it, because the consumer hasn't configured it yet, it just drops it on the floor. So everyone is safe at this point. We're done our work, and now someone's just waiting for the consumer to go ahead and configure it to go where it needs to go. Now, they go along and develop their consuming code to deal with 2.0, and it's time for them to test it. And that's what they'll do. They'll go into the configuration, set it up to route it to a new Kinesis stream for test purposes. They're on their own. And when they get through their testing cycle and are happy with it, they can go ahead and promote it up their stack till it's into production. And that's what they'll do next. So with that, we're completely decoupled. We moved at our pace, they move at their pace, they're in control of their destiny, we're not going to break them. The last thing we needed to deal with, that I said to complete our bus ecosystem, is security governance. Now this isn't code, this isn't anything that the engineers had to do, but it's thinking about the security options that are available to us within Amazon and communicating with everyone, including our partners, and collaborating with them and deciding how we're going to move forward with security. It amounts to policy, practices, and procedures, classic governance. So you have to do that, you have to think about it, you need to evangelize it, collaborate, coach, do whatever it takes to get everybody on board with that, write it down, and then follow it. It's a step we had to take, it's a step anyone would have to take. So let's look at a retrospective now. We took on a mission-critical data streaming challenge because of syndicating the X1 platform, where data became a first-class participant in that platform. It's not an afterthought, it's a feature. And we tried to do it in-house. We encountered some struggles. We decided to pivot and go with managed services. We told you about some challenges that we had with the in-house version and how we expected the managed service approach to change some of that. Well, so far, our mean time between failure has been infinity because we've never had a failure with Kinesis. So far, the mean time to recovery, of course, is 0 as well. Multi-tenant guardrails, which I mentioned were missing from Kafka, they're in place and they're clear and they're enforced by the platform. The elastic scale is okay. It's an API. I would like it to not be an API. I would like it to be as easy as it is in Firehose. So go Amazon. And thirdly, the security is great. IAM, SAML Federation, cross-account trust, they're all there to make a decision about them and use them how you see fit. And fourthly, multi-data center high availability is there. Now it's time for you to think about it. If I've done my job well, as I said at the beginning, maybe you've got some ideas from what I've mentioned in our story of how you can apply some of this. Maybe you've got a workflow that's kind of static, kind of traditional ETL-like, and you'd like to think about streaming, or you've got a new thing that's coming along that really would benefit from streaming. Maybe you've been tackling streaming and maybe facing some of the same challenges we were facing. Either of those are candidates for taking on an experiment. You might want to decide whether you want to go high visibility and maybe high risk, or low visibility, low risk. But pick a data flow, preferably a new one, and get an eager developer or two who wants to get involved with this and maybe get the resume perks from doing it. Pitch it to an end consumer, even if it's inside your organization, your team. And that's an important step. Getting used to pitching it and advocating something that's quite different is a good thing to go through. Choose a schema approach. It really matters. Don't neglect this. No good having data flow through that nobody knows how to interpret. Decide on a real-time processing framework. Spark, Storm, AWS Lambda, Kinesis Analytics, any or all of them. Build a producer proxy to get data into Kinesis. Don't necessarily ask for the producer to do that for you and get them all ramped up on how to do Kinesis. Take it on yourself as a proxy for them. Build a consumer to get the data off Kinesis and get it somewhere useful. Maybe it only needs to be at rest somewhere, like S3. That would be easy to do with Firehose. Or maybe you want to send it somewhere so an ETL process can pick it up, even though S3 is a great ETL pickup point. And lastly, evaluate that whole cycle and decide how it went for you and iterate and do more. So there's our story. Remember to fill out your evaluations. We want to know if this was useful for you. And Liam and I will be here right now to answer questions, and maybe even a little longer if they go longer than that. Thank you.
Questions if you want. We can do some on-stage questions or take them down off to the side. Any questions? Yeah, there's a mic up for the questions. Or if you yell it, I can repeat it for the camera as well.
OK, so just a pretty simple question. You mentioned previously you guys had different topics inside your data bus environment. And I know that's a native concept inside of Kafka. What did you guys do for that in your Kinesis environment? Were they just separate streams? Or
yeah.
OK.
Yeah, we just consider streams equivalent to topics.
OK, cool.
Yeah.
Thanks.
Any other questions?
When the Avro data flows through Kinesis Streams and you have a Firehose, the Avro data is not really plain simple Avro. Now it's modified Avro with a header and the payload, and there is a schema lookup to create the final proper Avro file in S3. So how do you do that in the Firehose?
We actually don't. We just stream it as we've created it into Firehose, and it's sitting there in a mangled Avro form.
It's not Avro. Okay.
Right,
Okay.
Right. We don't bother creating containers. We've encountered a couple of scenarios where people, subscribers would like us to do that, and we could do that. And I would probably do it in Lambda. You know, take up a whole bunch of stuff, periodic in batch form, and create an Avro container and send it out to S3 that way.
Okay.
Yeah.
Thanks.
Hi. You mentioned about the schema registry, that thing. So how do you maintain that in a separate like cluster or in a database? How do you maintain? Because that's kind of a single node of failure, because if that fails and everything.
Right, right. So our standard with everything in X1 is high availability, active, 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 everything. So the same for that. So that registry is in 3 data centers. I think it's all in Amazon, actually.
Everything in Amazon?
Yeah, it's all in Amazon. The front end is all a web farm distributed across 3 AZs, just in one region. And then the backing data store is, I believe, DynamoDB.
Oh, okay.
Yeah.
And one more question. You have used Kafka right before, and Kafka make use of partitions to partition the data. How do you use that in Kinesis? Or you have never used in
How do we partition?
concept of partitions?
Yeah.
They use.
It's really the same thing as shards, I believe.
Okay,
yeah,
okay.
same thing.
Okay.
Yeah.
Okay. Thank you.
And by the way, I want to emphasize this is not a bash of Kafka at all. It's a showing that taking on Kafka is a big undertaking. Plenty of people do Kafka really well, and Netflix in particular did it in a pretty HA way by doing it in Amazon, by just distributing the cluster across 3 AZs because the network latency is so slow that you can get by with that. So it's not at all a bash on Kafka. It's just what we were trying to do was more than our particular team could actually succeed with.
Hi, good presentation. Just one question. From a technical analysis, why did you use Avro as a message specification over, say, protocol buffs that's a little bit more specific for messaging?
Right. We were liking the fact that, of course, the binary encoding was good, and the idea that it was actually possible to separate out the schema. We could figure out how to hack it and pull the schema out and not affect it. There's also some things on either side, like when you're using Java objects to handle the consumption of the registers. There's Java generic objects and Java specific objects that you compile to the actual schema to make the object ready to interpret the Avro schema that we liked as well. Okay. So those are some of the factors.
Okay.
Make sense?
Thank you.
Yeah.
I think last question.
Maybe a couple. It's more around the fact of Avro and the schema that you actually more hybridized the schema. Maybe you answered this question around, did you actually input that in conjunction with your registry into any of the processing engines to do any of the analytics, or is it just for the streaming, have not used it for analytics yet? Because I'm trying to see whether I can actually try to use that format for an analysis purpose, because it actually might work, technically might work if I have registry as robust as you're talking about. Did you do any of the analytics on that file?
So yeah, I think I understand your question. Is this fairly proprietary message flying by might not work so well in a streaming analytics application? Is that it?
Yes.
Yeah. And have we tried to deal with that?
Yes.
So the answer is we would have to pull the schema down in real time and have it in cache in order to interpret it for analytics purposes, because it is binary encoded. So even if we hadn't mangled it in any way, it's still binary, and it doesn't serve very well for real-time analytics. You have to decode it into full JSON ASCII text, right?
Yes.
In order to make use of it.
Have you done that?
No, we haven't. It's not that we haven't tried. I mean, we haven't even tried, because it hasn't been an application we're that concerned with yet. But we'll have to get to there in order to take more advantage of, for instance, Kinesis Analytics.
And that's where something like Lambda comes into play. So you would actually take it off the stream, use Lambda to shape it into a different format, and possibly push it into another Kinesis stream that you can then run your analytics on. For something like Kinesis Analytics, that would be the current methodology.
Yeah, it'd be nice to have adapters in there that know how to deal with Avro, for instance.
It would.
Yeah.
Okay. Thank you.
Sure.
And we'll be around here as well a little later. We actually have some of the Kinesis team. I see them floating around the audience here. So we're around if you have any questions.
Thank you. Thank you.